Now, more about light. You know that a light ray can be produced from a luminous body. What is this light ray made of? The earlier understanding of nature of light was given by Newton in the form of corpuscular theory. This theory could not explain certain experimental observations about light like diffraction and interference. Later on, Huygens propounded the wave theory of light. The wave theory of light. When a stone is dropped in a still pond of water, the disturbance travels in the form of waves spreading in all directions. The point where the stone touches the water acts as the source of water waves. These water waves are circular in shape. The Dutch physicist Christian Huygens assumed that the light travels in the form of waves from a source, which is called wave theory of light. According to Huygens' wave theory of light, the propagation of a light wave requires a material medium. According to Huygens, the medium is an all-pervading subtle and elastic hypothetical medium called ether. A luminous source sends out light energy uniformly in all directions, causing disturbance in the surrounding ether medium. These disturbances travel through ether in the form of longitudinal mechanical waves. Concept of wavefront and light rays. The basis of Huygens' wave theory of light is its principle concerning construction of a wavefront, the imaginary three-dimensional surface formed by the envelope of all those particles of a medium, which are vibrating in the same phase, is called a wavefront. Huygens' principle states that every point of a wavefront behaves as the source of small secondary wavelets, which spreads out in all directions with a velocity equal to the velocity of light. The new wavefront is then found by constructing a surface tangential to the secondary wavelets. Further understanding of light was given by Maxwell's electromagnetic theory. Electromagnetic theory. James Clerk Maxwell studied the phenomenon of electromagnetic radiation and properties of light. Maxwell discovered that self-propagating electromagnetic waves travel through the space at a constant speed. From this, Maxwell concluded that light was form of electromagnetic radiation. In 1873, he published a treatise on electricity and magnetism, which contained a full mathematical description of the behavior of electric and magnetic fields, still known as Maxwell's equations. For complete understanding of various phenomena exhibited by light, both particle and wave nature are attributed to light according to modern quantum theory. Quantum theory. In 1900, Max Planck described quantum theory, in which light is considered to be composed of discrete packets of energy. These packets were called quanta, and the particle of light was given the name photon to correspond with other particles being described around this time, such as the electron and proton. A photon has an energy E related to its frequency f by the following relation. EF is equal to HF is equal to hc/lambda, where h is Planck's constant, E is the wavelength and c is the speed of light. As it originally stood, this theory did not explain the simultaneous wave-like nature of light, though Planck would later work on theories that did. The Nobel Committee awarded Planck the Physics Prize in 1918 for his part in the founding of quantum theory. The modern theory of light. The modern theory that explains the nature of light involves the concept of wave-particle duality, described by Albert Einstein in the early 1900s, based on his work on the photoelectric effect and Planck's results. Einstein determined that the energy of a photon is proportional to its frequency. More generally, the theory states that everything has both a particle nature and a wave nature, and various experiments can be done to bring out one or the other nature of light. The particle nature is more easily made out if an object has large mass. In 1924, Louis de Broglie conducted an experiment which helped to realize that electrons also exhibited wave-particle duality. Einstein received the Nobel Prize in 1921 for his work with the wave-particle duality on photons, and de Broglie followed in 1929 for his extension of wave-particle duality concept to other particles.